All right, so here we've got an application problem. So it says a mining company operates two mines, each producing three grades of ore. The West Summit mine can produce 2 tons of low grade, 3 tons of medium grade, and 1 ton of high grade in 1 hour of operation. And the North Ridge mine can produce 2 tons of low, 1 ton of medium, and 2 tons of high. Now, to satisfy existing orders, the company needs to produce at least 100 tons of low, 60 tons of medium, and 80 tons of high grade. The cost of operating each mine varies depending on conditions while extracting the ore. If it costs $400 per hour to operate the west and 600 to operate the north, how many hours should each mine operate to basically minimize that cost to production, and what is that minimum cost? All right, so let's write down some things here. So we're going to have some variables. So let's let x1 equal, well, let's do it the west mine hours, and let's let x2 equal the north mine hours. I think that's what they were looking for. And so what we want to do is we want to minimize cost, it says. And it's going to be what? Well, it costs 400 to operate west, so it's going to be 400 x1, and it's 600 to operate north plus 600 x2. Okay. Now, and it's going to be subject to. Now, what do we have here? Now we have to find the 2 tons of low and the Northridge can do. So it's going to be 2x1 plus 2x2. And then it has to do at least 100 tons of low. So it has to be greater than or equal to 100. Then we have 3 and 1 and 60. So it's going to be 3x1 plus x2 greater than or equal to 60. And then here it says 1 high, 2 high, and has to be 80. So x1 plus 2x2 has to be greater than or equal to 80. And our x1 and x2 greater than or equal to 0. Okay, so I think this is our original problem. We want to minimize the cost when it's $400 per hour times the number of hours of X1 plus $600 per hour times the number of hours of X2. And then we just have all those constraints based on, let's if we highlight those, where West Summit can be 2 tons of low, maybe we should go low grade, 3 tons of medium grade, and 1 ton of high grade. And here we have 2 tons of low grade, 1 ton of medium grade, and 2 tons of high grade. Then we have to have 100 tons of low, 60 tons of medium, and 80 tons of high. And it's $40 per hour and $600 per hour. So all those items are how we get to those equations right there. All right, so with that said, now we have to find A and A transpose. So let's do A. Okay, well, that's going to be what? That's going to be a 2, a 2, a 100, and then it's going to be a 3, a 1, and a 60, and a 1, and a 2, and an 80, and then a 400, and a 600, and a 1. So that's my A. Again, that's my X1, X2. Now, A transpose. Now we're going to go down. So 2 to 100, 3, 1, 60, and 1 to 80. Can't read my own handwriting. And then 400, 600, and 1. So it's going to look something like that. And so now we're at Y1, Y2, Y3. All right, so let's write our dual problem. So the dual is going to be, we're going to maximize P equals, now we down at the bottom, we have 100 y1 plus 60 y2 plus 80 y3. And it's subject to, and now we have 2y1 plus 3y2 plus y3, and that's going to be less than or equal to 400. And then we have a 2y1 plus y2 plus 20y3, and that's going to be less than or equal to 600. Is that really a 20 there? No, it's just a 2. 1, 2. I don't know why there's a 20 there. So that didn't make sense. All right. So we got our 2, and then less than or equal to 600. And then what do we have? A y1, y2, and y3 have to be greater than or equal to 0. Now, what we have to do is we have to convert it to the E system. And so with the E system, we're going to convert to that and we're going to have our xi's added. So we'll have what? A 2y1 plus 3y2 plus y3 plus x1 equals 400. And then we'll have a 2y1 plus y2 plus 2y3 plus x2 equals 600. And then we take that over, so it's going to be a minus 100y1 minus 60y2 minus 80y3 plus p equals 0. And y1, y2, y3, x1, x2, x3 all have to be greater than or equal to 0. So then this is going to be the problem we put into our simplex tableau. So that's going to have to be on the next page because we're out of room already. And so it'll be, let's see here. We have only two variables on the left here, x1, x2. Then we have our p like always. And then we have y1, y2, y3, x1, x2. And then we have our p. And so that was a 2, a 3, a 1, a 1, a 0, a 0, and a 400. Then we had a 2, a 1, a 2, a 0, a 1, a 0, and a 600. Then we had what? Minus 100, minus 60, minus 80, 0, 0, 1, and 0. Okay. Now, the biggest negative is this one. And so our quotient is going to be what? 400 divided by 2, which is going to be 200. And then we have 600 divided by 2, which is 300. Well, that one's the smallest, so that means that's going to be our pivot point. And so we're going to enter here and we're going to exit here. And we're going to have to take 1/2 of row 1, and that's going to be our new row 1. If we take a minus 2 row, no, not minus 2, just minus row 2, not too many 2's here, a minus row 1 plus row 2, and that's going to go to the new row 2. And if we take 50 row 1 plus row 3, that's going to be our new row 3. All right, so we have y1, y2, y3, and then x1, x2, p. And this is now y1, and this is still x2, and this is still p. All right, so now we have to take half of that. So that's going to be 1. It's going to be 3/2. That's going to be a 1/2. That's going to be 1/2, 0, a 0, and 200. And minus that plus that's going to give us a 0, a minus 2, a 1, a minus 1, a 1, a 0, and a 200. And then we're going to 50 times that plus that. That better give us 0. That's going to give us what? 90. And then minus 30, 50, 0, 1. And that's going to be 50 times that's going to be 20 with 3 zeros. So 20, 1, 2, 3. Okay. Now, smallest number here is going to be this one. So we'll take for our quotient, we're going to take 200 divided by half, which is going to be 400. And we're going to take 200 divided by 1, which is 200. So that's our smallest. And so this will be our pivot point. So we're going to enter with this, and we're going to exit here. And so this one we don't have to do anything to. So we can take a minus a half of row 2 plus row 1, and that's going to be our new row 1. And we can take 30 row 2 plus row 3, and that's going to be our new row 3. All right. So doing that, what do we have? Now we had a y1, and then we had a y3, and then our p. And we have y1, y2, y3, x1, x2, p, and a line. All right, so here we have, we're going to keep that second row. So that's a 0, minus 2, a 1, a minus 1, a 1, and a 0, and then a 200. And then we're taking a minus half that row plus the first row. So it's going to be a 1, 5 halves, a 0, a 1, minus a half. Oops. So x1 is going to be a 1. Then it's going to be a minus 1/2, a 0, and then that's only be 100. And then we add that up as 0. That'd be 30, 0, 20, 31. And now we add that together, so that looks like 26,000. Yeah, I think so. All right. So that gives us our final thing because guess what? Those are all zeros, so we're going to stop. And so now we want to minimize the cost, and that's going to be that number there. So it's going to be 26, 1, 2, 3. And x1 is going to be what? X1 is going to be 20, and that's hours in the west mine. And x2 is going to be 30 hours in the north mine. And that will minimize the cost based on all the information that was given in our problem, which basically, these are the number of tons of grades of different ores and how much all that stuff costs, which gave us our minimization problem here. And then this is what we just solved with these values here. All right, let's stop there and we'll come back for one more.